Thank you for the nice introduction. It's a pleasure for me to present the project, the risk estimation with the learning AI. So the output of the project is the AI-based tool chain to identify in real-world scenarios the edge cases and also to transform it in car maker files, which you can upload to the car maker so that you can really simulate directly these edge cases in the simulation, and you also get this kind of variance. So my name is Freudenmann. I'm the CEO and co-founder of EDI, Engineering Data Intelligence. So the name here is program. We like to semantically link the data. So this is why I'm also working on the semantic web. And we provide AI-based decision models. And here we are using these AI-based decision models in the automotive and autonomous driving area. But in this project, we were working also with strong partners together. First of all, with IPG. So also with IPG, I personally have a really long relationship. During my PhD at the IPG, we started the first project in 2008. So that's a really long time. And also there was already the focus on a test scenario manager. So now we continue this work since a long time, and we provide here a browser where you find your edge cases. So that's also a test scenario manager. But also we have partners from the region here. We were working together in this project with Fraunhofer from Karlsruhe and from Stuttgart, and as well from the University of Stuttgart. So what is the aim? So also today we hear a lot about it, but in general, the 90% of all accidents happens because we not have the right speed. And the right speed we have maybe not, because on the left side, upper left side, you can see the person estimate the driving situation in the wrong way. So this is why he gets kicked out of the road. But on the left bottom side, you can see that the behavior of the opponent, in this case the pedestrian, was not how we expect. And also today we already hear that this kind of expectation really influence our driving behavior, and if such things happens which we not expect, accident is quite possible. And these are really old movies from Germany, so the people maybe which are a little bit older here in Germany knows this. It's from the Seventh Sense. So they are far away from conventional, from autonomous vehicles, but the situations for conventional cars and drivers and for the autonomous vehicles are the same. You have to predict the driving situation in the right way, and you also have to estimate the expected behavior of the opponents as well in the right way. Also today, we already hear a lot about that we need a lot of test kilometers in the real world, that we can be sure that every test we cover and every situation we cover. And with IPG car maker, we have the possibility to generate the variance, but also we have to understand what happens in the real world. And also what we have to say, we are not waiting for the autonomous vehicle which is driving alone through the streets, what we also already have, but also I think in every car are a lot of automation driving functions, traffic jam pilot, line keeping assistance, following assistance. All these kind of functions have to work that the driver or the passenger in the vehicle get a good feeling, but also that the opponents, pedestrians, people on the bicycles, but also other cars get a feeling that everything works. And that's exactly what we were doing in this project. We want to analyze what is the expectation of the behavior of the driver of this kind of vehicles or of the autonomous vehicles, but as well what is the expectation from the pedestrian perspective. And before we are starting this, before we were starting as EDI this project, we had a long-term project also with two universities aus Japan. So also Professor Inoue is really well known here at IPG. So he was a former manager from Toyota. And we started 6 years ago with a project because we found a data treasure, and that was there is a database with more than 100 critical incidents which are recorded in Tokyo or bigger cities in Japan. And the value of this database is because we not only get this kind of movies, what you can see here, the taxi has to brake in a special situation because this opponent is crossing the street in a really strange way, an uncontrolled way. So also the expectation was a different one. So this is why he has to brake, and then automatically this kind of file gets stored in this incident database. So we have exactly with this kind of videos, 15 seconds videos, we have more than 100,000 incidents. But also we analyze not only this kind of videos, we have the advantage that there was traffic experts from Japan which was manual labeling all of these incidents with more than 100 labels. And you can expect that the Japanese people were really accurate. So we have a really long list here where we have information about the infrastructure. For sure, we know what kind of one-way or two lines, but also different intersection types were labeled. But also we have a lot of information about the opponents. For example, if the opponent was dashing out, how was his behavior, he was swinging on the road, and also we have the label if the pedestrian was drunken or not. So also that could happen in Japan if you are in special areas that you will find some drunken peoples. And this kind of information we had in this database, and we were trained our machine learning models, our cluster algorithm based on these situations. And also what we get is the information how critical was the accident or the incident. For sure, and that's now really important, if you have an accident, in the many cases, the ego vehicle and the opponent are still standing afterwards. But if you have a low incident, also we hear sometimes maybe the pedestrian is not crossing the street, even he is dashing out, then already the ego vehicle can accelerate again during these 15 seconds. And this special speed shapes we were also using to train our algorithm to identify later this kind of critical edge cases. So what we can say is we find edge cases where the ego vehicle has some typical speed profiles in braking, and we can also evaluate how critical these edge cases was in the reality. So I will show a slide where that gets much more clear again. So, and I mentioned we are also working here together with strong partners, and so the important thing on the right side you can see a driver which makes a lot of other things instead of driving. So I hope he has autonomous vehicles because he is searching for his laptop, and you can see so the Fraunhofer IOSB are using here some algorithm to detect the behavior of this person, and he's not looking to the laptop itself, so he not have an object detection of the laptop. He has an object detection of the whole behavior of the skeleton, and that makes it really robust to identify activities. And we were also using this kind of approach for the behavior of the outside of the pedestrian. And also you can see here the eye and the nose. So this is really, he trained the model on this skeleton, and that makes also the model more robust. And also it makes it easier to train, so you can also scale your training speed. And also from the Fraunhofer or the University Stuttgart and the Fraunhofer from Stuttgart, they have a strong environment also to bring the stuff in the virtual reality, I will say. So also we have at the end solutions where people can wear glasses that we can really validate if we really find edge cases. I also will show this, how the project's results are on these cases. So again, I mentioned it in the beginning, we built up an AI-based tool chain which allows us to identify in real-world scenarios. So that could be test drivers which are driving around in a moment. So on the highway you see a lot of cars with some symbols that there is a camera inside, because from the suppliers to the OEMs, the people want to gather data to understand what happens in the traffic, if our system works in the right way. And in the good thing, we also hear, in many cases, nothing happens. So that's a good thing in the reality, but for the test driver and for to validate and to improve the systems, that's not the best case, because then you have to drive a lot of things or a lot of kilometers to understand if your system works, and we exactly cut out automatically this kind of critical situations and bring it into a database. And also here we are using, as I mentioned, the algorithm again from Fraunhofer EOSB to get some automatic labeling things. And also we have an algorithm to transform the relevant objects into a car maker readable file. It's called info file, so that you not have this manual work to bring the real behavior of the ego vehicle and the opponent manual into the simulation. You just can import it. And at the end of this chain, we also validate that these edge cases which we find are also really edge cases, and also what is the expectation from the humans and from the pedestrians, from the other traffic opponents, if we are driving with real autonomous vehicles. So that was also a research topic of our research partners in this project. I will also show here the results. So again, what we are doing here is we get real-world data, and here I mentioned two open data sets which you can find from US. So there are Waymo data set, and from Berkeley, for example, we also had, and in both cases, you will find around 100 traffic situations. In these situations, a lot of traffic situations are included where nothing happens, so no critical incident happens here. And with our algorithm, we filter out the critical one, and it's around 1% from Waymo and 1.6% of Berkeley, when we are using our algorithm, which we calibrate based on the database that we have from Japan. So overall, we also analyze some other data. We were analyzing around 500,000 critical incident situations. So also we have a really nice overview what happens in the street and when critical thing happens. And here again, you can see to find these critical things, we were exactly using this kind of behavior clusters from the ego vehicle. So, and also here we have the possibility to evaluate automatically how critical these incidents are. We from EDI, I mentioned, we are coming from the semantic web. We are providing AI-based algorithm, and in the keynote we hear the guy from AWS, which has a really nice speech. So in our case, we could run exactly on his environment. So we are also Docker-based. So that means we can use our algorithm in this layer which he presents. So we could also provide, for example, if you are running your IPG car maker in the cloud environment, we could provide this kind of analytic things directly there. So we have the possibility to include also external models into our environment and run it also scalable. So we are also Kubernetes based, which helps us to manage these things. So for example, we include the models from Fraunhofer. So we are also really happy to have these third-party models. And I also ask these questions because I think in the keynote, because I think not everybody has to do the same thing again. To share and to work together in these challenging situations are really important. Here again, a few to this AI-based toolchain which we built up. So on the one hand, if you have recorded files, if you have camera data, we can use this. We can also work with existing databases like Waymo, Berkeley, but also from your company. If you already have a database, then we can run our algorithm on this database. At the end, we identify critical scenarios. We can give some additional labels so that you also have the possibility to semantically find this data again, that you can focus on special cases, for example, cases where a lot of pedestrians are available, cases where a lot of trucks or other vehicles are available. So this kind of labels we can set automatically. And I mentioned as well that we have a possibility to focus on the relevant objects in a scenario. So there are sometimes a lot of parking cars around. that's not always really interesting and overloads your simulation environment. So I will say we kicked out the objects which are not really in the focus of this incident, and we provide this as an info file which you can upload in a car maker, and it's also attached to this incidents. So if we go inside of one of these objects, so one object is one edge case which we found in the real world. For example, here we have the example from a Waymo data set where you can see on the right side playing childs, exactly the example which our first presenter also had. Yeah, so there was playing child, nothing happens because the child was not really dashing out, but the driver already behaved in a careful way because he was responsible about these situations. He had the eye on this playing child, and this is why we cut out this event. And in our case, we want that the suppliers and OEMs systems behave also in a way that they already reduce the speed before something happens. So we are not waiting on an emergency brake that maybe it's good enough to not avoid the accident. The important thing is that you reduce the speed if you see this kind of unexpected behavior in front, that you reduce the speed already. What I mentioned is that we also have an AI which gets out of this scene a bird eye perspective. Also here the important thing is we build up the deep estimation, so we understand where are the other objects based on the ego vehicle. And so this is why we can also interpret this kind of unexpected and expected behavior. And if you look to the bird eye perspective, you can already see on this running around arrows that the behavior is not really clear, so it makes quite sure that a vehicle should avoid this kind of situations such close on the street. So in the last step, you can download this info file and you can upload this scene in IPG Car Maker, and what you get out is a basic scenario. You can also see again these flying childs, and also you can see the vehicle which maybe hits some sensor signals. And also together with IPG, we enrich this scene, for example, with some buildings. Also, you can bring in some sunlight. You could also saw in the last slide that this kind of shadows and sunlight also have some influence, for example, on the camera systems, if you want to recognize these pedestrians or these people or flying childs next to it. So that's exactly what you can do as next. And then you can also have the possibility, we saw also in the keynote in the morning, really nice, that you can generate this kind of variants. So from the real world edge cases, you can generate 1,000, and then at the end you are quite sure that your system behaves in the right way in this situation. Here we have one other example, and here you can also see this kind of boxes around, so which we know from the object detection algorithm. And that's exactly what we also provide in this project, that if you upload a video material without object detection, we have an algorithm to identify these relevant objects. So that's also a possibility that we can anonymize these objects, because especially in Germany, that's a really important issue, that you upload in your database somehow data which are keeping the privacy of the people in mind. And also what we have here, it's exactly what I mentioned, it's the estimation of the deepness. So if you upload this kind of video, we can estimate the position of the relevant objects. And so we also have the possibility to generate out of a video material this kind of bird eye perspective, so that you also can simulate it again in the reality. So also here you can see already from IPG we get a video where we enrich a little bit with buildings next to it. So that was a manual work, so that is not the output of our AI. But also what we are planning, for example, is if you have the sunlight, that we can also bring in this kind of different sunlight into the simulation directly. So you can upload in a further version also this to our application, so then you have the possibility to have enriched simulation files which is belonging to a real world edge case which we found in the data, and so at the end you get a really good understanding if your system are working well or not. So at the end, what we as EDI provide, I said we have a cloud-based version from this. Is a web application, so you can use with a tablet, with your smartphone, you can analyze your data, you can upload it, you get out exactly these annotated values. What we have here, it's an app store for autonomous driving. We have an incident detector, which you can, where you can upload 1 hour or whole day test drive. We automatically identify the critical one inside here. And I'm now connected, so our servers are in Nürnberg. So it's the German AWS version, a little bit smaller. It's NetWays, but so the data in the moment are stored in Germany, but we can also run, for example, we have a project where we are running on a Daimler hybrid cloud, so also this is possible. We can also run in intra-server system. At the end, you have, this is a longer file where we identify, for example, 2 edge cases, and if you go to one, then you can navigate also to this edge case, and then you get exactly the labels and the videos, and that's what I show you in the screen. So that's exactly what is our idea. So in the incident browser, you have listed all your relevant edge cases which you need for tests. For example, there could be also for the NCAP some relevant tests inside, which also have the corresponding CarMaker file uploaded so that you can use it directly in the tests. Yeah, and what we provide here, it's a kind of app store. Yeah, so you can see we have different applications. We also store some raw data of the ego vehicle, which you can have some basic analysis. But we also have other projects for autonomous driving. For example, our project Go Safe, where we are working together with the PTV group. So that's also a company here from Karlsruhe, also a spin-off from the KIT, so founded 40 years ago. EDI is founded 7 years ago. I think IPG is 48? 38. It's a little bit the same, yes. So, and also I really like these 2 companies because, as I will say, they are doing really well in how you can make from a spin-off from the KIT or the University of Karlsruhe such an international company out of it. So we're working together here with PTV because the PTV group is about traffic flow simulation, so they are not focusing really on the vehicle dynamic, and this is why we have with GoSafe the possibility to predict critical intersections in a new traffic concept where you then, for example, can, if you make other concept, other intersection type here, then we can estimate how more safer this concept is against to the other. And for the city planners, that's are really important if you think about new concepts, because it's not only about the performance, so a roundabout has a high performance in the traffic, and it reduces also the critical incidents because the speed gets down. So these are things which we include in this application. Yeah, so I will summarize also the validation step. So we had this data from TUAT. We also have the nice possibility here in Karlsruhe with the test field for autonomous driving. So we were also searching for places which are exactly what we saw in the Japan TUAT incident database. Also, we have the US data, so we were also comparing in a scientific way a little bit how transferable these things are. And for sure, you saw already in the US, the infrastructure is much wider. So for sensor signals, it's different. So there it's, for example, the infrastructure of Japan closer to the infrastructure of Germany and the EU. And at the end, we put everything into the simulation, and we make some study with some students, and that was running on the Fraunhofer Institute. And also here, what we find out, and that's also, I think, really interesting, and it's somehow quite sure. So it was about the distance when a vehicle should brake and with which kind of speed the vehicle should come to the pedestrian. And we could find out that it's different if the pedestrian could see a driver in the driving or as a pilot, or if there is nothing, because that was changing a little bit the expectation how fast and when a vehicle should brake. So that is what we can see here. And here we also were using some standard modules from our EDI Hive to analyze this data. And in the last step, so that was exactly how we make this study to identify what is the expectation. So you could saw in the video that the pedestrian was crossing the street. So in this case, we were analyzing the pedestrian, and on the other side, we have the 3D motion capture, where we were bringing in the behavior of the pedestrian into the simulation. So at last, I will say a lot of thank you to all the partners. So I already mentioned our directly project partner, but also it's really a pleasure that we could include in this German-founded project, which was running 3 years, also our partners from Japan. We also were including the test field or Baden-Württemberg, which is here in Karlsruhe, so as partners. So that was a really nice project. And maybe as an outlook where we are already working on it, not only critical traffic situations are edge cases for autonomous vehicles, it's also if the sensor sometimes not can see everything, so it's about context sensing situations. For example, if you have a bright sun in a special angle, then you not can see the objects. And here we are working on, and we bring it again also in this incident browser. Then you can select between critical incidents from traffic perspective, but also from the sensor perspective. And if you are interested in our solution, then please contact us. Thank you very much.